Hello. So the talk will be in English. It's a pity that we South American people have to use English to communicate to each other, but I don't really do Portuguese. But so if I speak too fast or maybe too weird for you to understand, just please correct me, and I will try just to repeat. Okay. So a little bit about myself. I have been working with a free and open source software multimedia related projects for, I think it's around like 15 years or something like that. I've been involved in some of the projects that we are going to touch today. I'm an active contributor for GStreamer. I used to be a maintainer for FMPEG. Now I'm doing that back. And well, I work for Samsung. We have this neat open source group inside Samsung Research America in Silicon Valley. And I will tell you a little bit more about it later, okay? So this is a high-level talk. Like, my idea is just to present you with well, actually, FOSS Multimedia really means. We are going to touch on some projects that, well, I just handpick for you to understand how projects relate to each other. And then I will provide you with some contextual information that it might be interesting to you. And at the end, I will just tell you a little bit how are we going about this with Samsung and why are we doing it that way. So I'm guessing it's interesting to speak a little bit about what's multimedia in this context. Multimedia is a large subject, and in this particular talk, we are interested in the lower level bytes that just relate to the multimedia processing pipeline that is present in most of your applications. So why multimedia? Well, human beings are really like excited about trying to port this sensory system that we have to the computing. Ever since we have computers fast enough, we have been trying to deal with video, image data, and sound data. I'm guessing at some point we will try to pursue other alternative way of communication, but right now we are really focused on video and audio. So we are going to approach this multimedia subject using the two similar directions, the production one and the consumption one. And as I mentioned, I will just concentrate on the main areas that are related to those processes. So in producing multimedia content, you will usually be dealing with your multimedia pipeline, your processing pipeline will be sort of a massive like analog to digital converter. Maybe it will go even to analog after you finish. And you usually just find this kind of processing stage that goes from capture, maybe audio, video, then you encode it, you mix it to produce something that computers can actually understand, and then you go and store it or transmit to, well, you might want it to transmit to some internet link, or you might want to show it on the screen. That's optional, but that's pretty much what you find when you talk about multimedia processing and the production direction. Then going the other way around it is exactly the same, just the end line, the end points of the pipeline are different. So you will be getting or reading some multimedia file or content. You will be trying to figure out what is inside it. We call that muxing. We'll go demuxing. We will briefly explain that. And well, you will decoding, and then we will render. So that's a lot. But that's actually an attempt to a joke. And that it's just saying that it's the exact opposite process than the production one, okay? So in reality, most multimedia use cases are more complex than this. You will usually have extra elements that perform some other kind of task. You can have a parser, for example, in between, or several parsers. You might be dealing with files that have not only audio, not only video, but some picture data, subtitles, and each of the individual stream will require the same kind of logic being duplicated. Okay? So even though it seems complex, I'm guessing, are you multimedia developers? Are you multimedia users? What is your approach? How many of you actually develop multimedia applications or something like that? You? You do? You don't develop applications, man. And then I'm guessing the rest of you are multimedia users? Just, okay. So you mentioned that you develop multimedia applications? What are you working on? Blender. Okay, so that's, for example, one particular aspect of multimedia that we are not really going to touch in this talk. We are just going to concentrate on the processing bytes. Okay, well, there is a lot of processing in doing 3D modeling and stuff like that, but we are going to just focus on the other side, okay? So, as I was telling you, if you go to study how multimedia processing works on a regular computing pipeline, you will find these, say, 4 operations repeated over and over and over again. Okay, so we are going to introduce what they are, what they do, and then we are going to relate these functional units with actual multimedia, free software, multimedia software that perform those tasks, okay? So at Capture, you will be interested on bringing your multimedia content originally in the analog domain to the digital one. Okay, so, well, it doesn't necessarily mean that you are going to be just processing video. Audio is, well, a particular popular use case too. And you will be going then from the outside of your machine, the outside of the computing domain, to the computing one. So it's a endpoint that marks the beginning of a production pipeline in multimedia. So for our friends, Blender, for example, you will be capturing, maybe you will be actually producing your own multimedia material to feed the pipeline with. And encoding, after you capture, you have a, well, in the old days, we'll say that after you capture, you have just pure analog data, but the reality of it is most capture hardware perform this preliminary analog to digital conversion for you. So you will be usually be dealing with digital data after a capture stage has finished. So once you capture, you have all this digital data, you will quickly realize that it's huge. Like just for an image, the amount of data at the resolution that we are working right now is huge. So the idea of encoding is to get this data and transform it in a way that is convenient to you as an as in multimedia application. Okay, so why do you convert this data? Is because you're usually interested in tackling 2 particular challenges. So you're interested in trying to compress this data, because dealing with raw data is just, it's not that it's too hard, it's too computationally intensive. And you will be interested in being able to reproduce this operation, if not in real time, at least in close to real time. In multimedia, when we talk about real time, we refer to playback time. Okay, doing things in real time as such, it's real time. It's not even well defined, but it's not only that, it's really complex and hard. So you will be using your knowledge about a particular signal domain for being able to compress this data, okay? So when we talk about codecs, we talk about functional units that perform this magic, okay? So for example, we know for long ago that human visual sensory system is more sensitive to luminance change than chroma change, for example. And that's something that GPAG explodes to be able to discard some of the color information and try to focus on the luminance information. So you will, well, color and luminance are closely related, but in the nature they come separate, okay? And so you will be designing a codec like GPAG that will be compressing the signal, losing some information, to be able to get a stream that is more like a small, easy to process, and that you wouldn't usually be able to notice any difference. If you look at a JPG image compressed at a decent quality and at a good resolution, you will usually not be able to tell the difference between the original capture and the JPG file. So that's the idea of those kind of codecs. So after, well, decoding is going the other way around. You have the same logic, but backwards. So you will have the same codec performing the other operation, which is going from the encode domain to the uncode domain afterwards. So when I'm approaching the subject, I'm approaching them from the production direction, but then I'm briefly referring to the backward operation, so you get a feeling of what is. So decoding is what you will be doing at playback, for example. So anyone has a sheet of paper, by the way? Some paper? Do you have some sheet of paper? No? Yeah? Do you have a sheet of paper? I do this attempts to teach people about multimedia processing regularly, and just to enforce the concept of encoding, you will be capturing and you will be getting some information. Okay, so let's imagine for a moment that whatever is written here is the information that we need to encode. It's important to remember that encoding is not only about compressing data. There are also looselet codecs that actually don't compress or don't lose information on compressing. And it might, I mean, if you go really, really down below to the definition of encoding, you might end up arguing that even color format conversion is a form of encoding, for example. But anyway, so you get your data, and you have this magic algorithm that just compresses it some way, okay? So you will originally be able to understand the image if you were working on RAW, for example. But then after you encode it, you will have something like this. So something that most people wouldn't be able to understand. And the vast reality of it is that most programs won't be able to understand encode data neither. So why is this important? Because we are going to use this one for the next topic. So I was just telling you there are a lot of codecs to choose from. We will see that codecs in general are quite a mathematical kind of subject. And there's a lot of research and development being done on codecs. Like even as we speak, people are trying to find newer, faster, and well, less complex, or at least working better on commodity regular hardware to represent this data. So codecs is an area that moves really, really fast. If you consider the whole multimedia processing pipeline, you will notice that coding and decoding is actually the most complex part of it. So there's when hardware vendors started trying to optimize this, going lower level and implementing this logic in the dice itself, they focus on the codec and decoding area at first. So at the beginning, we only had like accelerated codecs. Now we can find accelerated codecs, accelerated demuxers and muxers, but originally this was like the common ground for hardware optimization was encoding and decoding. So after you have your signal capture and encode, you will be trying to figure out how to distribute this stream. So that's when muxing comes into place, and muxing is given your seemingly random encode stream. You will be dealing with more than one usually. You will be trying to give it some meaning at the file domain, okay, or at the stream domain. So you will have, for example, two code streams. So you will have audio and video, And you will be wrapping around these two streams in some kind of container. So that's an important concept. You will be wrapping around it some kind of container, okay? It might be a good container like, I don't know, Matroska, for example, or it might be a really, really bad one like ABI, for example. So after you mux the stream, you will have something like this, okay? And this is a file or a stream, something that your computer will store on your hard disk, and something that your multimedia application will have to deal with at the beginning of their processing pipelines to do playback. Okay? So when talking about muxing, we'll be referring to like saving this file to this, but I'm pretty sure you understand that that's not the only use case for a mux stream. So the muxing is the exact opposite process. I don't know where you attend Tiago's talk on multimedia introduction and just streamer, but he went around this. I'm just going to reinforce it. So you will have a file, and you will have a multimedia application that gets the file some way, like a file reader and a stream reader. And it will try to detect what the file type is, and then once it detects it, it will figure out whether it supports the format or not, and it will be demuxing the stream, okay? So it will grab this piece of paper and it would like just unwrap it around. And it will get the two code streams that we had in the beginning. So once we demux the stream, we are back to or two or more, like one or more code streams. The render stage is, well, that can be pretty much anything, I guess. In the most common use case, if you are the one using, I don't know, MPlayer Totem just to watch a video on your stream, well, rendering will be showing this content of your screen, so you will be able to see it. So it's back to the analog domain in that case. So it's not really analog, but in the end, from your monitor to your eyes, it's analog, so that's what's important. And that marks the end stage of a playback type of pipeline, so the consumption type of pipeline that we were referring to initially. So the whole multimedia processing challenge, the whole logic being like really, really high level about it deals pretty much with that. So it deals with capturing, rendering, coding, decoding, muxing, and demuxing. Okay? So after we have this like initial knowledge, we'll be able to talk using multimedia terms to describe what's come next, which is an overview of an actual free software multimedia system. Okay? So the talk is designed so you will ask questions in between. So if do you have any questions? If you don't ask questions, we'll take like 10 minutes and we will be done. So do you understand perfectly what coding is, where the coding is, where muxing and demuxing is? Okay. So we gotta, you sure? Okay. Am I going too fast at it, or you are being able to pick up what I'm trying to say? It's okay? Cool, thanks. So we have these functional units around, like, as we mentioned, the coding, and all that. And the multimedia processing challenge in the software domain deals with figuring out how to make it work together. So it can cater our need of reproduction or consumption or production. So, well, I already asked you if you had questions. So, FOSS Multimedia is not in any way different than proprietary multimedia, by the way. It's just that it's what we do, so it's FOSS Multimedia. But most of what I'm going to say, except the examples that are like FOSS related, you can just say, consider it a generic software approach to multimedia processing. So it will work for Windows, it will work for Mac OS, it will work for anything. So these are completely made up acronyms, so don't take notes. These are mine acronyms, so to refer to these functional units. And we will discuss briefly these 4 stages and what kind of software is involved in each of them, okay? So We have in Italy what I like to call the deep sea enablers. They usually deal with I/O, like ways to perform this original capture that we mentioned, or the rendering at the end. Moro here is an expert on that field, so if you have any questions, you can just ask him. And well, good examples of these deep sea enablers. I call them deep sea enablers because using the generic high level and low level kind of approach to describe complexity and programming, these are really, really close to the bare metal, close to the machine itself. Though there are multiple examples. We have Video for Linux, which deals mostly with capturing. Well, dealt mostly with capturing. Then DBB came around, and then you are doing some multimedia processing inside it too, and trying to understand the signal that you're getting and all that. So the deep sea enablers provide the rest of the programming pipeline a way to capture and render. It's basically just that, okay? You will find most of this inside the kernel. It's not user space level software, but you will find like libraries that will let you go from user space to kernel space when dealing with this, okay? So Mauro, for example, was talking yesterday, presenting briefly the DBB, libDBB version 5, which will let you perform digital television kind of operations on DBB, ATSC, and ISDBBT stream. And that's a user space library, isn't it? Okay. So after these deep sea enablers, we will have these functional processing units. And this is why I think that things start to make sense, because you can actually map these functional processing units with what we were discussing briefly just a few minutes ago. So you will have software like FMPEG, libAV, which will provide you with these pieces of software that perform just tasks, and they try to do it like effectively. So you will have codecs here, you will have the muxers at this level too, and those will deal with just one single operation. It will be, for example, I don't know, MPHG decoder, or it will be an AVI demuxer, or AVI muxer, XSoft, soft picture decoder. So the joke there is that, as I was telling you back then, this is actually usually the most complex part of multimedia processing inside your software stack. So as an user, I'm guessing you might be dealing directly with this kind of tools, but it will be for single shot tasks, not that complex, that you can usually, if you can usually see you scripting whatever you want to do, you might get around it using these lower level software tools. Okay, so as I was telling you, this functional processing unit provide this unical task pieces of software that you can use to perform one of the operations that we already discussed. Now, if you wanted to, I'm going to when I describe this different like software stage in the multimedia processing domain, I will go about it as a user and as a developer, okay? Because I have the benefit to work as a developer with them too. So I wanted to just to give you an overview of how those kind of community works. So if you wanted to approach this functional processing units, if you wanted to be a developer for FMPEG, for example, or libAV, you will be well served if you are really interested in the low-level mechanics of it. If you have or like strong maths, if you have this kind of curiosity, that will drive you towards there, because it's not really a rewarding kind of place. I mean, like most people won't even notice the work you're doing. And one interesting thing is that these communities, yeah, you can come in. We are short on people. And so what happens with these communities, this is something that I have personally experienced, is that in general, the subjects that they deal with are really, really complex, and you find these like great minds working on this kind of project. There is a reason why there's just FMPEG and libav. They are you will see afterward that it's basically the same. There's no other project that I know of that is trying to develop like free software implementations for software codecs in the FOSS world. Or maybe I'm updated and you know about some other alternative. If you wanted to do, I don't know, like a H.264 like decoding using something, you will probably just go to FMPEG and grab whatever the guys did. So, same for BBH or whatever. So it's a complex kind of subject, and the people that are involved in the development of these solutions are usually kind of, I don't want to say freaky, but they're usually kind of like, I don't know, like people you will usually need a drink to talk to or something, okay? And there are a couple of like nice happenings around these communities. And it being not a technical talk, I figured, well, I will tell you a bit more about that. Like, this is what I lived through. So I have like 3 short stories to tell you here about this community. So first one I want to tell you, I want to refer to a guy. His name is Fabrice Bellard. Have you ever heard of Fabrice Bellard? Okay, cool. So you think it's worth mentioning here? Yeah. So Fabrice is, well, I don't know the guy. I mean, I've just had the pleasure to work with his work, but he seems to be some kind of genius, or he actually is some kind of genius. And I put it on the title, The Great Escapist, is because this guy seems to have this, I don't know, inclination towards starting really, really successful projects, and then he just disappears. It's like really, really weird. Like most people like me, being like regular people, normal people, will try to enjoy the fact that we managed to produce something useful. But this guy just does something and then just abandons the project and then moves to do something even cooler somehow. So actually he started FMPEG, and when he started FMPEG, he started using a pseudonym. It's like, you know, like the old way of starting a book and saying, I'm not Reinaldo Verdejo, I'm Tiago Santos or something. And after that, he started Kemu. Have you know about Kemu? Like the machine emulator is also a project by Fabrice Bellard. And if it's one of these guys that is famous enough to have his own Wikipedia page, and you can go do some research, and you will find him, I don't know, like winning twice the International Obfuscated C Code contest. You will find him holding a world record on the fastest algorithms to determine the greatest known PI full digit number. You will find him having a formula called after him, the Bellard formula, which is a formula, it's a binary approach to determine digits of P. I think he held the record for like five years, something like that. Someone took it from him. The interesting thing that he used a regular computer to do it. So it was quite significant. And the guy is still alive. We don't know it. We don't know him. Like, I don't know. I have never met someone that actually knows him. I was talking yesterday with Michael Niedermeyer, which is another one I want to tell you about. And I asked the guy, like, do you know anything about Fabrice? And Michael himself is a really, really smart guy, right? And he told me something like, I don't know, he's a genius. Like, I don't know what else to say. So this is an interesting character. If you want to know more about like him, you can just go look at, you can Google his name, Fabrice Bellard, and you will be amazed by the amount of stuff that he's doing. He was lately working, for example, on developing, he actually developed a way to produce a DBVT signal using just software and a VGA card or something like that. And the plans are there on their website. So it's really, really like ridiculously smart. Okay, so Fabrice, that's an interesting character. He started FMPEG, he started Kemu2, and then we go to this another guy. Okay, this guy is from FMPEG too. And the guy name is Michael Niedermeyer. Do you know about Michael Niedermeyer? Okay, so this was like really, really long time ago. When I got involved in multimedia, it was like, I don't know, like maybe 2000 or something like that. And I originally got involved with MPlayer, and as you might know by now, that MPlayer, FMPEG, VLC, they share a lot of the development base, you know, like most people will be, for example, developer on MPlayer and FMPEG, and later just got fed up with the player and just moved to work on the codec side. So this guy's name is Michael Niedermeyer. So the funny thing about Michael Niedermeyer is that even though I was working in a community full of really great developers and really smart people, I don't consider myself to be that smart, to be honest. I just got lucky in some way. And no one really knew the guy, okay? And he worked at a speed that was like really, really, I don't know, like if you spend like all the day in front of your computer, you won't be able to come across what he was doing. He was reviewing, I don't know, like 40, 50 patches a day. He was doing, I don't know, like 20, 30 commits. No one even find a single flaw in what he was doing. He was like, I remember, I was young though, but I remember that there was this rumor going around the community that the guy wasn't actually a guy. That there was like several persons working under this team pseudonym called Michael Niedermeyer, which was really weird. I mean, like, these are smart people. Like, these are not idiots. And they were thinking that Michael Niedermeyer wasn't just a single person. And the thing is that Michael, because we will figure out soon that he is an actual person, didn't want to share an IRC neither, which increased this suspicion of him not being a regular human being, you know? And, well, years passed by, and we found the community involved in a conflict that I will actually mention now. And there is when we figured out that Michael was an actual person, okay? So, are you aware of the libav FMPEG situation? Okay, I will tell you about it. So, at some point, this was around 2010, I think. I might be like loose on the actual dates, but it's around 2010. Another great developer came out. I mean, they were in FMPEG. They were really, really good developers. Like all hands down. Like everyone was good in a way or another. But there's always these special people. These people that are actually like, I don't know, like special. Like they are not regular in a way. So there was this other developer, which I have a highly respect for. His name is Mans. He was working for ARM, I think. I don't know whether he still works there, but I think by the time he was involved with the project, he wasn't a student, but that's just another story. What happened was that Mans was actually also a really good developer. And Michael has this style of working with the community in a kind of dictatorial way. Like he will be the one reviewing everyone's patches. He will be the one calling the shots on anything that he didn't like. And most people didn't really have a trouble with it because he was just so good at it. Like you didn't even feel in a position to argue. Like, if he was saying that your code sucked, then you just went ahead and write it again and problem solved. But when you happen to find two similarly smart guys working on the same community, it will be kind of hard not to end up feeling like, for the other guy, feeling like this position of power wasn't really justified. And it might be a good reason to think about that, to think that way. So there were several members on the team that were like uneasy about the situation. And they decided to throw a revolution, like a real revolution, you know, like mails going around saying we need to, like, derogue Michael, we need to kick him out of the project. Whether it was justified or not justified is just another issue. Most people would say that it was actually justified, but the way it went around was really, really bad. So it actually involved, you know, after the emails, after they like wanted to throw him off, they actually tried to like capture the hardware, like re-own the DNS records of FMPEG and destroy the mail list. So Michael was kicked in a kind of an hostile way. I personally don't think he deserved that kind of treatment, but that happened. And I think they actually managed to capture the name too. So LibAV was for a short while, like maybe a few days, a FMPEG. But then Fabrice, that had the right to, I mean, he has just registered FMPEG as a, I don't know whether it's a trademark, the correct term, but he owns the. He supported Michael. Many developers actually supported Michael, not because they were totally cool with the way he was with the community, but it was most about hating the way everything like turned out. It was really a bloody revolution, you know, like it wasn't a friendly way of doing it. And well, Fabrice sided up with Michael, which is the only intervention that I have seen from Fabrice's life. And so the name got with Michael. So the project split, and the same code, and now we have FMPEG and LibAV. And you have, for example, in Debian, you will have LibAV, because from what I understand, at the time, the maintainer of the package, the FMPEG package for Debian, was also one of the members of this revolutionary team. So he just switched from FMPEG to LibAV. And then in LibAV, they found this kind of like regular open source development model in which you will have like all your patches reviewed, and every single change will go through a review, and then you will be able to commit. And they are trying to ensure a more stable code base. They are doing regular releases and stuff like that. So, by the time FMPEG wasn't doing that. And FMPEG just continued with the usual model of the community, the working model, in which Michael will be the one ruling, and he is by large the most like significant contributor to the project anyway, to the point that we thought that he wasn't a real person. And he will have some general. So it's similar in a way to the way that the Linux kernel is developed. So you will be a file maintainer. FMPEG has file level maintainership. So you will be, for example, Reinaldo Verdejo in charge of, like FF server or some random stuff like that, and you will be the one usually just committing to that code. And review is a posteriori, it's not a priori. So if I'm working on a really complex change that I want to be reviewed, like beforehand, I will just send it to a list. There is a list in which you can do that. But if I'm fairly confident that it's good code, that it does what it's intended to do, I will just commit it. And well, every single developer will get this notification, and they will be able to say, okay, it works, or it doesn't, that it has this problem. So what happened is that FMPEG now is moving faster than the LibAV, to the point that some people are trying to push it back to Debian, for example, which is a hard to win battle. And LibAV continues being successful in a way. It's packaged by pretty much every single distribution, I think. And well, as a community, they are more friendly with the rest of the world, so they are more popular, I would say. And that was it. That was the FMPEG revolution. So when one important thing is that Michael, fast as he is, he keeps like tracking down LibAV, and he just regularly merges the change that happened on LibAV, and he tries to maintain a certain degree of compatibility, AVI and API compatibility between the two projects. The LibAV folks, maybe there was just too much animosity going on. They won't. They will sometimes just merge one or two patches from FMPEG, but in general, they don't really care about FMPEG. So the divide between the teams is actually whether LibAV is a fork. They say they are not a fork because, well, it was the team that split. From the FMPEG side, there is a fork. And what you have to remember is that at this level, like with this kind of people, like smart people, like egos are super strong, and these communities tend not to be like for the faint of heart, I would say. So they managed to do that. And I don't know whether there's another history on the free software world that was as violent as the FMPEG LibAV breakup, but so I thought it was worth mentioning. So after you have this functional process unit, you will have a development frameworks, okay? So you will have this massive, generally functionally complete library or set of libraries and tools, and that will wrap around the functionality provided by this functional processing units. So in these categories, you will have projects like FMPEG, for example, and, like GeoStreamer, for example. I'm just going to refer to GeoStreamer because, well, we know it's the most important framework anyway. And so as a user, you will rely on frameworks like this if you are basically a developer. I mean, you can do, GeoStreamer provides some ways for you to, I don't know, work prototyping multimedia processing pipelines in the command line, for example. But the purpose of GeoStreamer has always been to provide a programming framework. Okay, so if you're a user of GeoStreamer, you're either a user by association, you're using something that uses GeoStreamer down below, or you are just developing with it. And I think it's worth like telling you a little bit about how GeoStreamer works, because if you are interested in doing some sort of multimedia development, or if you are some kind of advanced user, you might want to know how it works, because GeoStreamer supports pretty much all multimedia use cases in your regular desktop. Even the, I don't know what's the current status with the KDE folks, but they use Phonom. I think Phonom had a GeoStreamer backend too. So GeoStreamer is pretty much everywhere, and it's everywhere in the industry too, not only in the community. So GeoStreamer has this neat concept. They will provide you with a, well, GeoStreamer is just highly like dynamic kind of a library in which you will have this sort of functional unit wrapper called the element, and the element will connect to the rest of the world using paths, which are like connection points. And you will have sync paths that are paths able to consume data, and you will have source paths that are paths able to produce data. And with these elements, which are actual, like, GeoStreamer is based on GeoObject, the element is a GeoObject. And with these elements, you will be able to build up, like, multimedia processing pipelines, which is really neat. So, for example, that might be, I don't know, for example, that might be a file reader there up front, and then you will have, like, I don't know, like, that might be a capture device, and then you will have two mux data streams. Have a muxter by each one. So each one of these small dices are a functional processing unit wrapper over one of the FPU that we mentioned before. So for example, FMPEG will provide a BPA decoder, and then GeoStreamer will provide in return an element called GST BPA decoder that will just wrap around the functionality provided by the FMPEG element down below. And it will let you do this magic of connecting, reconnecting at playtime, for example, and be able to drive this kind of highly dynamic processing pipelines. And they go even one step ahead further with this, and they have developed this concept of a bean, which is basically a pipeline, a full pipeline that acts like an element to the outside world. So it's a really neat design. So if you are interested in GeoStreamer, actually, there is a tool that you can use on the command line. This tool is called GST Launch. And if you know a little bit about multimedia, you will be able to draft a functional pipeline and make it run on your console, which is really neat. If you are, for example, prototyping a particular multimedia use case. For example, you mentioned that you work with Blender, isn't it? Okay, so you mentioned that you work with Blender, isn't it? So you may be wondering, okay, I have this rendering of this neat, like, I don't know, 3D scene, and I would like to see how well it gets, I don't know, like, encoded by this particular codex. So you will, in the command line, you will easily be able to just build a short pipeline to encode and move your rendering and see it working like right away. Or you might want to mix two of your scenes or whatever. So GeoStreamer does that. If you're a contributor, I already mentioned that we are going at this introduction as a user and as a contributor. You might want to get involved at communities like GeoStreamer if you are interested in providing this kind of functionality to other applications. So if you are enabler, okay, of functionality. So one thing that is really, really nice about communities like Just Dreamer is that at the level they work, even though there are still like really, really nice and highly talented developers, the community is far more mature. So, for example, this Just Dreamer is used on the industry, like really, really used on the industry, and maybe it's related to that fact that it's a mature community. Like people won't be, I don't know, like calling names, people won't be trying to route revolutions, people won't be trying to hostility kick off someone from the project or anything. So these are mature communities. So even they are even suitable. If you are a new developer and you want to get involved in multimedia development, I would highly recommend Just Dreamer. They're like really helpful people. They will teach you and try to walk you toward the basics of multimedia. And if you put some effort, you will be able to like collaborate with them, work with them, without having any like hard time doing whatever. So it's a neat, nice community to be involved with. And by here we are approaching the end of it, and you get to the user-facing applications. Okay, these are the actually applications you end up interacting with, and well, these are just 3 examples I come up with. I'm trying to mention things that I've worked with or developed with, these are the kind of applications that you usually get involved with when you don't know nothing about it. So you will, I don't know, you had a file you wanted to play, you were like, I don't know, 10 years old, you were using some kind of Linux, and you just double click it and a player show up and show the playback your file, and you were dealing with a user-facing application. So as a contributor, if you wanted to approach one of these communities, I already mentioned that most of these communities share some of their developers. So for example, in the first player and VLC, you will have FMPEG people around there. And if you are into Totem and some more like GUI-like playback application, you will find people that are, in a way, are not involved with Just Dreamer too. So if you wanted to approach this community as a developer, I would just like to tell you that these are really, really, really I'm having a hard time trying to find a word for it, but these communities can get really nasty sometimes. So it might deal with the fact that maybe approaching multimedia development from an application point of view allows pretty much anyone to, I don't know, if you are like a regular computer programmer, or not even a computer programmer, professional computer programming, but if you are into programming in any way, I'm pretty much sure that with the tools available, you will be able to throw some kind of player application in, half an hour or anything like that. So the reality of it is that most of these projects started being just that. So as it's easy to get involved with, you will find a lot of like youngsters around, not really mature. I mean, I'm not saying that every single project is like that, but I'm going to use one example. So it was around year 2001, 2002, yeah, multimedia in the free software world was really young, and a guy baptized and player the project from hell. This appeared in a Linux word entry around that time, and the writer was impressed by the quality of it. Like it was being able to, but by then there weren't that many players around, and in player works. In player world, it was using FMPEG to like do the low-level processing. They had their own demuxers and stuff. But the problem is that they were being highly offensive with their users, for example. So you will read a manual from a player, and they will be actively insulting their users. And I know this was true because I was involved in that team by that time. And it was not only insulting the users, it was insulting the user, their critics. So this guy, Joe Barr is the name, he had the idea of writing about M-Player, the project from hell, as he called it. And, well, the community reacted to, and M-Player wasn't really having problems just with them, just with the media. It was having problems with Red Hat, for example, because Red Hat had decided to ship one compiler was not like completely, I don't know, flawless. It was like 296, I think, which was a Red Hat version of 295, GCC 295. So there were like many projects having some trouble with it. So you work for Red Hat, so okay. So I'm going easy on you. So so yeah, so they fight pretty much with everyone, and it was really common to see fights in between the team too, so people being hostile against each other. So it's, I don't know, for me it was kind of about times of fire or something like that. Like when people tell you about growing a thick skin when working on the FOSS community, that they're referring to these kind of projects. It's cool, you can learn a lot. There are a lot of nice people around anyway, but maybe it is because it's so easy to enter these communities that you tend up like finding this kind of behavior. It's funny, like it's funny before they hit you. Like, okay, so I'm not saying they are bad. I still have highly respect for people involved in Emplayer. Emplayer was actually got me into free software development. So, but it was, I mean, I have never seen in the press calling a project from hell. It actually the guy meant, and actually the guy had some reason to do it. Okay. So piecing it together, I know that this talk had like random information for everywhere, but just to make sure you understand the point of the functional processing unit and the enablers and all that, we have the deep sea enablers that we mentioned, pieces of software dealing mostly with capturing, rendering, stuff like that, and you have this limit represented there by the black line. That black line is the kernel limit, so you will have your kernel space in the green dot. Then you have the functional processing units. You will be dealing with projects like FMPEG, libav, and they will be just codecs, demuxer, single-purpose units that you can use directly, but you will rather go one step above, and you will be dealing with the multimedia frameworks like GStreamer, and you will be having an easier time trying to work with this functional processing unit using one of these frameworks. And at the end, we have the user-facing applications that actually build on top of this. So if you wanted, for example, to come up with a new multimedia player right now, I don't know why you will want to do that, because there are several, but anyway, if you wanted to, you will be working with GStreamer, for example, and GStreamer will be taking away the complexity of dealing with FMPEG down below. And FMPEG in return will be dealing with the lower level bytes of, I don't know, like rendering using OpenGL or XV or whatever, or reading from a video for Linux, say, a device. Well, GStreamer can do the same. Actually, I mentioned that the codecs are what differentiate this project the most, because the only real collection of codes that we have in the open source world, software implementations, is FMPEG and libav, which is the same project, basically. So, because it's the most complex part. So, if you go to GStreamer, for example, you will find re-implementations of some of this stuff, but not the codecs. I mean, you will find some codecs implemented, but let's be really honest with you. Most projects after that differentiate on the rest of the functional processing units. Like maybe they touch the muxers and muxer. Maybe they have their own. But if they are going to, no one is actively trying to reinvent the wheel on the software decoder implementation, for example. And we have some nice tales about that. So, for example, at some point, Google published a reference for the BPH codec called BPX. And then the FMPEG community come up with an implementation that was faster than Google. So they are really good at it. So most people are not trying to rewrite that, okay? So short note about the industry. So the industry use FOSS Multimedia, like they use like a lot. And the problem with the industry, I'm going really quick at this because I'm already exhausting the time. The problem with this is that most of the industry won't tell you so. So they won't admit that they use free software, okay? So this is not YouTube, this is ShootTube, okay? And for example, like most people were wondering if this big broadcaster was using FMPEG. They never were clear about it. We never got an answer about it. But it was weird that FMPEG was working on really, really fringe formats and codecs, and suddenly this site started to support them. Like, it was like really obvious that something was going on there. On the other side, Samsung, we use free software. And we have discovered that we weren't doing it that good before. We weren't very clear about it, and we weren't trying to support the communities actively. And well, we are being really clear now. We do use free software. 2 of the projects that we mentioned, well, 4 of the projects or 5 of the projects that we mentioned, JetStreamer, FMPEG, Video for Linux, all that, we are using it, okay? And we are trying to be open about it, and we are actually trying to collaborate with the project. Okay, so time is over. I don't know whether you have any quick questions. I don't want to steal time from the other presenters, so I will be around the whole day. And thanks for joining me for this session. Hope it was successful, okay?